This is ReactCast's episode 12, Server-Side Rendering. Server-side rendering means rendering your React components on the server before sending them to the browser. And what is the advantage of that, you say? Well, in a regular setup, the server would usually send a blank HTML page that would be populated by React on the browser. That is, once the JavaScript file containing both React and your application code downloads and runs. Server rendering React components can lead to a better user experience and in some cases, better search engine discoverability. Instead of sending a blank page and letting the browser do all the work, we can render your components on the server into static markup. A page containing pre-populated data is then sent to the browser. When JavaScript runs, React will mount your components, realize that there is already some content in the page, and just take over from that point on, adding front-end interactivity. Sounds nice, doesn't it? That's only possible because the React library itself is isomorphic, also known as universal, which means that it does not contain browser-specific code. Its JavaScript can run both on the browser and on the server. Now, the React DOM package does contain a browser-specific function, render, but it also contains a render toString function that we can use on the server to generate static markup, and that's the main ingredient in this recipe. But before we get coding, there's one very important aspect to consider: compiling and module systems. You see, it's now commonplace to have a build system going on the front end. We start with a module bundler, which allows us to split our project into multiple individual modules, and a compiler that allows us to use things like JSX, which is not standard JavaScript, because the compiler will transform it into plain JavaScript function calls for us. In the React world, Webpack is the most popular module bundler, and Babel is the most popular compiler. Even if you're using tools like Create React App, Webpack and Babel are used together under the scenes to generate your bundled JavaScript file. On the backend, the story is different. We usually have more control over the environment. We don't have to compile code to support a multitude of possible browser vendors and versions, and Node.js, which is the server technology we are going to use, already has a built-in module system. But rendering React components on the server, including JSX, is a different beast. We will need to include at least a compiler because, once again, JSX is not valid JavaScript and it needs to be compiled. Talking about modules, Node does have a built-in module system, but it's not the same ES6 module system used on the front end. They're mostly compatible, and if you want, you can use Babel to transform any ES6 module-related code into Node's module code. It will work, but you will have to settle down with a limited set of functionalities, especially comparing to things that Webpack enables, like importing CSS and image files directly from your JavaScript code. If you want the whole package, then you will have to use Webpack to bundle your server files as well. Alright, enough talking, let's get to some code. I want to code my components just like I would do if I were using Create React App, importing CSS and image files. So my solution will include a build step for server files using both Babel and Webpack. But first, let me guide you through the sample project I already have in place here. I have a public folder where the bundled JavaScript file and other assets will be saved into. My source folder contains 3 subfolders: browser, server, and shared. My React components will actually live in the shared folder, since they will render on both the browser and the server. Let me open my app component here. Pretty straightforward, as you can see. It imports CSS, an image, and renders some markup. The main index file on both browser and server are empty. Before working on them, we have to set up our build configuration for Webpack. I have already installed React and React DOM, so I will start by installing the dev dependencies. I will install Webpack and Babel Core, our 2 tools on this build process. I will also install Babel Loader, which allows them to work together. Now, both Webpack and Babel need additional packages for every feature we want to enable in our code, such as support for JSX, new JavaScript language features, importing asset files, and so on. To create a similar experience that Create React App provides, we need to install Babel preset React App, File Loader for asset files, CSS Loader for CSS, Post CSS Loader and its plugin Autoprefixer, and finally Extract Text Webpack plugin. Yeah, it's a long list, but you can get the full transcript at the React-Cast repo. The link is on the screen. Moving on, Webpack automatically searches for a configuration file named webpack.config.js. I already have one with some bare bones imports and exports. We need two configurations, one to bundle client-side JavaScript for the browser, and one to bundle server code. As you can see, we can export an array of configurations and Webpack will run all of them. My browser configuration is already pointing to the correct entry file. It's generating files on the public folder. My server configuration is also already pointing to the server's index.js, but notice that it has some additional information to target Node.js and use its module system. Let's start by adding configuration on the module object. First, I need JavaScript files to be compiled, so I will include all files with the JS extension, but not in the Node modules folder. These files will be loaded by Babel. The exact same configuration applies to the server. Back to the browser configuration, I want to be able to import image files. To do that, I will paste the required loader here. As you can see, it tests for common image file extensions. If it finds any import statements for these file types, it will copy the actual file to the public folder and return its URL. I will not dive into many details here because the focus of this show is on actual code and not Webpack configuration details, but I will link to the documentation on the show notes and on the repo if you want to learn more. For style sheets, I will actually start by using the Extract Text plugin, which will gather all imported CSS and bundle them into a single file. Then, I will use the CSS loader and also Post CSS loader. Post CSS is not required to work with CSS, but it's very common in the React world. You can think of it as a CSS transformer. There are lots of transformation plugins available, and I'm using the same one that Create React App uses by default, Autoprefixer, that, well, automatically adds vendor prefixes to your CSS rules. As I just said, notice that both style sheet and image configurations will save actual files into the public folder when Webpack runs. The file loader does that automatically, but I need to finish the extract text configuration by adding the plugin with the desired file name. Good, the browser configuration is done. Let's move to the server configuration again. Because I'll render React components on the server, I also need the same file and style sheet loaders in my server configuration as well. But I do not want to actually generate the files and copy them to the public folders again, right? That would be a waste of resources and time. Fortunately, that can be done with small changes in the original configurations. I will begin by copying the file loader and simply adding emit false, which means do not copy the files. Now, the style sheet configuration can be radically simplified. Since I don't want to generate files, I can get rid of Extract Text plugin and Post CSS. The CSS loader configuration stays because the server still needs to be aware of CSS imports without actually using them. This can be done by changing the loader to a different path, locals. This configuration is rather smart, and as a side note, it is also compatible with CSS modules, in which case it will make sure to generate the correct class names on the server and place them in your components when rendering. That's basically it. We have a build set up. there are lots of room for improvement here. We could do a little refactor to avoid repetition. Most importantly, split the configuration files to create not only a production-specific config, but also a development one where the files are served from memory instead of copied. But I'll leave it as is for now to focus on actual code. Alright, we are more than halfway through. Hang in there. Let's focus on the browser and server codes. Let's start with the easy one, the browser. Nothing new here. I will import React, import the render function from React DOM, and import my app component. Then I'll use render, my app component, in document getElementById root. That's all. Now let's move to the interesting part, the server. I need to create an HTTP server, and to make it easier, I will install Express, which is the most popular server framework for Node.js. In my server's index.js file, I will import Express. I will also import React from React. But instead of importing the render method from React DOM, I will import render2string from React DOM/server. Finally, I will import the very same app component. Now, I will create a new server by invoking Express and set it to listen on some defined port or 3000 by default. Let me console log that the server is indeed running. Next, I will instruct Express to serve any static files from the public folder. Finally, for any other route, I will render an HTML page. When loaded by the browser, this page will fetch the browser's bundle.js, and it will also contain a root div where React can mount. These alone would be enough for React to run, but the whole purpose of this episode is to send an HTML file pre-populated with the rendered content, right? And now that we have all the setup in place, it's as easy as render2string app. And that's all. The last piece that we are missing is a start script. On package.json, I'll create a start dev script that does two things. Runs Webpack to bundle both browser and server files, and runs the generated server file. All of these in development mode. Enough waiting, let's test. Cool, we have a React application pre-rendered on the server. To be 100% sure that the HTML came indeed pre-rendered from the server, I will show the source code that was delivered to the browser. Aha, here it is. The component was indeed rendered on the server and the page came pre-populated. So, to recap, rendering React on the server can lead to a better user experience and, in some cases, better search engine discoverability. You will need two Webpack configurations, one to bundle files for the browser and one for the server. But while the browser configuration will actually generate and bundle image and CSS files into the public folder, the server configuration won't. On the browser, when JavaScript runs, React will realize that the component is already there and take over for front-end interactivity, skipping the initial render. Moving forward, there are still at least two essential topics regarding server-side rendering complete React applications: routing and data fetching. This episode is over, but these topics will be covered on the next episode, so don't forget to subscribe and click on the bell icon to be notified when it's out. You just watched an episode of React Casts. All the source code from this episode is available on GitHub, github.com/cassiozen/reactcasts. Once again, I'd like to give a big thanks to Full Stack Academy of Code for all the support. You guys made this episode possible. See you on the next episode.